James Webb Telescope discovered alien in Proxima B exoplanet. The James Webb Space Telescope is shaping up to be one of humanity's most significant space observation breakthroughs. The scientific world has great hopes for this space telescope because it is significantly more powerful than any other space observatory ever deployed by humanity. It will allow them to examine far-off objects in space in ways that they have never been able to before. Proxima B will be one of the objects studied by the JWST to investigate if the planet has artificial lights. Yes, you read that correctly. Scientists want to know if the lights from Proxima B are caused by extraterrestrials. What will the JWST see when it zeroes in on the exoplanet, and how will this influence you? Join us as we explore the revolutionary James Webb artificial light finding on Proxima B. Exoplanets are found all over the universe and hold a wealth of information. Any planets outside of our solar system fall into this category. The majority of them orbit other stars, but rogue planets or free-floating exoplanets orbit the galactic center and are unattached to any star. While exoplanets are widespread, the vast majority have been identified in a limited part of our galaxy, the Milky Way. In fact, there are more planets in the galaxy than stars. Scientists may see compositions ranging from very rocky, like Earth and Venus, to very gas-rich, like Jupiter and Saturn, by measuring exoplanets' diameters and masses with weights. Exoplanets are made up of elements that are identical to those found in our solar system's planets, although their compositions may change. So, certain planets might be dominated by water or ice, whereas others might be dominated by iron or carbon. Astronomers have discovered lava worlds with molten seas, fluffy planets, planets with the density of styrofoam, and planets with dense cores still orbiting their sun. Exoplanets were first detected in the 1990s, and many have since been discovered using various detection methods. However, astronomers rarely observe an exoplanet through their telescopes in the same manner that they could see Saturn through a telescope from Earth. Only a few exoplanets have been discovered this way, and they tend to be young gas giant planets circling quite far from their sun. Scientists must utilize indirect ways to detect these exoplanets because they are difficult to spot with existing telescopes. One indirect method is to observe the dimming of a star when a planet passes in front of it. The transit method is what it's called. Monitoring the spectrum of a star for telltale signals of a planet pulling on its star and causing its light to gradually Doppler shift is another way used to detect exoplanets. Observing transits, the little dimming of light from a star when its tiny planet passes between it and our telescopes, has led to the discovery of millions of planets. Gravitational lensing, often known as the wobble method, is another way of detection. Exoplanet detection is difficult, but analyzing them after discovery is even more difficult. As a result, astronomers haven't been able to fully investigate one of the most well-known exoplanets, Proxima B, despite all of the fascinating information they assume it holds. Is the exoplanet, for example, home to extraterrestrial life? They now have a new tool to work with, the James Webb Space Telescope. The JWST isn't the first human-built telescope in space. NASA has a long history of studying the universe with sophisticated observatories flown into orbit. The Hubble Space Telescope is one of the most famous and powerful, having reliably given spectacular photographs of various parts of the universe for decades. The JWST, on the other hand, is far more powerful and expensive than the Hubble. The JWST is the most expensive telescope ever launched, costing about $10 billion. It's also the most difficult, as numerous components are designed to fold up. They had to be folded in order for the telescope to fit on the rocket that would take it to orbit. In comparison to the Hubble, the JWST is a long way away. The former orbits the Earth at a distance of approximately 350 miles, while the latter rotates around the Sun at a distance of approximately 1 million miles. This means NASA won't be able to send people in to fix or reprogram the JWST once it's launched. The JWST's larger primary mirror, which measures 6.5 meters across, allows it to capture things billions of light years away, thereby transporting us back in time. In fact, because we can now reach as close to the Big Bang as possible, the JWST will allow us to take infant images of the universe. Infrared is used by the new telescope to pick up signals from heat-emitting objects thousands of kilometers distant. NASA installed a shield beneath the telescope to protect it from influence from the sun and the Earth's heat. The 5-layer shield is so large that it will cover the entire tennis court. NASA has released a mosaic of the JWST's initial photographs, depicting the early phases of the telescope's 18 main mirror segments aligning properly before it reaches its full capacity. While the image is grainy, it is a useful beginning point in the long process of calibrating JWST's mirrors so that ultra-sharp photographs of the distant universe may be taken. The 18 points of light in the image are all the same star, HD 84406, as seen via a different main mirror section. It took roughly 25 hours to collect the light that was needed to create the image mosaic. The 18 photos of HD 84406 were assembled from almost 1,500 photographs taken as Webb was oriented in various directions around the star's predicted location. Following the various adjustments that the telescope will make over the coming months, the mirror will begin to align appropriately, and the 18 stars will eventually merge into one as all of the mirror segments are aligned to produce a smooth surface. Why are astronomers interested in the extraterrestrial Proxima B? You must know where it is in order to comprehend this. The Proxima Centauri, around 4 light-years away, is our nearest neighboring star. Proxima Centauri, like our Sun, has its own group of planets around it. The planet Proxima B is one of the planets in the Proxima B system. Since its discovery in 2016, this exoplanet has piqued the interest of scientists. Proxima C and Proxima D have also been discovered, though Proxima D has yet to be confirmed. However, Proxima B has gotten a lot of attention, and for good reason. Because the planet orbits in the habitable zone of its star, it's plausible that liquid water, and possibly even life, could exist there. Because of its Earth-like mass, scientists believe Proxima B could not only have liquid water, but also be a rocky, terrestrial planet like Earth. Proxima B revolves around a star that, despite being close to our solar system, is much fainter and less massive than our Sun. The exoplanet is tidally locked and rotates in lockstep with its star, with one side facing the star and the other facing away, a light side and a dark side. Furthermore, it is unknown whether Proxima B has an atmosphere. However, if Proxima B has an atmosphere, the basic components for the production of biochemical cycles that we term life, water, carbon dioxide, and rock, might all be present and interacting on the planet's surface. The planet orbits its star every 11 Earth days, completing one orbit. The temperature on the planet's surface could range from -90 to 30 degrees Celsius, or -130 to 86 degrees Fahrenheit. What if Proxima B is inhabited by aliens? If that is the case, due to a steady stream of powerful radiation from its host star, it is thought that life could not develop on the day side. The explanation for this is because Proxima B orbits the Sun at a distance of only 4.5 million miles, or roughly a tenth of Mercury's distance from the Sun at its closest point. Radio transmissions have been discovered in the vicinity of Proxima B. However, radio astronomers believe this was most likely due to natural sources of interference. Because the side of the exoplanet that is free from radiation is always dark, any civilization that lives there may need to use powerful mirrors or demand incredibly brilliant LED-style lights to light its cities. This can assist us in detecting them using the appropriate tool. This is why a group led by Harvard astronomer Avi Loeb has proposed that the JWST be set up to look for signs of LED light on the planet Proxima B. They believe that by scanning for telltale signals of LED light waves in the light from the planet and its host star with the James Webb Telescope's near-infrared instrument, they will be able to discover this artificial light if it exists. The researchers used light curves from the planet and its host star to see if artificial lights might be spotted on Proxima B's dark side. These researchers looked at 2 scenarios: artificial illumination with the same spectrum as frequently used LEDs on Earth, and artificial illumination with a narrower spectrum that produces the same fraction of light as total artificial illumination on Earth. They revealed that the JWST could identify LED-type artificial lights that account for 5% of stellar power. If James Webb can detect the narrowband light that looks like LED bulbs, it'll be because he'll be able to define the planet's atmosphere. Researchers will be able to utilize devices on the observatory to detect how much energy is transported on the planet, and then calculate light curves to see if they match those of an LED light source or not. Loeb and colleagues utilized the JWST exposure time calculator to get to the conclusion that it might be able to detect artificial light. Before the observatory is launched, astronomers can use this program to estimate what can be observed in any particular time period depending on predefined settings. It allowed them to test the feasibility of detecting various flux values, as well as those with a wavelength that corresponds to artificial light levels that would be expected from a civilization forced to live in perpetual darkness. In such a situation, the lights beaming on the permanent night side should be exceedingly bright, making JWST detection more likely. The JWST will be able to demonstrate the existence of artificial illumination for conventional LEDs 500 times more powerful than those currently used on Earth, as well as artificial illumination of comparable magnitude to that found on Earth. Let us know what you think about the JWST discovering Proxima B exoplanet aliens in the comments area below, and thank you for watching.